Welcome everyone to the Tulsa.net user group. Tonight, Cameron Presley talking about rebuilding LINQ. This is going to be an exciting talk. We're going to deep dive into how LINQ actually works and a lot of the mindset behind it. So, Cameron, thank you so much for being here and giving us this talk tonight. I'll let you take it from here.
Perfect. Thanks, Sean. I appreciate that. As Sean has said, my name is Cameron Presley, and I'm here to talk to you about how you yourself could have invented LINQ. So before we get into the technicalness, let me tell you a little bit about myself. So I am based out of Charlotte, North Carolina, originally from East Tennessee. So for those in Oklahoma, sorry about the season earlier. Hope you enjoyed the football. I am a Microsoft MVP. All that means is that I love talking about technology and I love coaching and mentoring others. I've been doing that for a number of years now. Really enjoy that. I'm also a woodworker. So before the session, we were talking about lathe and doing creating and crafting. I do a lot of woodworking. I'm not particularly great at it, but I like showing people what I'm doing just because I feel if you work in the open and show your path, you're able to empower others to start maybe something scary, something new, something unusual. For example, maybe learning more about LINQ or functional programming. Last but not least, I am a professional tech consultant at a company called Lean Techniques based out of Des Moines, Iowa. We help companies make their IT awesome, right? So if you're running into issues where you're like, oh man, we could really use some help getting this done, or there's got to be a better way of how we're tackling these types of problems, reach out to me. I'm sure we can figure out something to help you out. But enough about me. One thing you get to learn about, you don't have to take any notes. Everything you're going to see tonight is already live. So if you trust me, you can scan the QR code on the screen. If you don't trust me, i.e. you're probably a security network expert, something of that sort, you're more welcome to go to the URL on the screen, blog.softwarementor.com/presentations. So that'll be the slide deck, code samples, everything. But with that being said, let's begin. Can I Google that URL? Ah, delightful. Ah, this is great. So what are we going to cover tonight? Oh, there's three concepts. First of all, we're going to talk about what is LINQ and what actually makes up LINQ. Without this foundation, it's going to get a little bit tough. Once we've kind of talked about what LINQ is, why it's so powerful, we're going to talk about the three things that make it work. And then we're going to show you how to implement what we call the trinity. So that's your select, where, and aggregate. But instead of just writing the code, I'm going to show you how you could have refactored production code into LINQ, assuming that it didn't already exist. So I could give you the textbook definition of LINQ, but that's boring. Let's look at some code. So let's pretend that we are working in this code base and we've come across this record type called delivery team. So delivery team has a name, has a team lead, and it's got a number of people on the team. So far, so good. Well, let's take a look at some example data. So I could have a list of teams. So we've got an alpha team, we've got back to the code, we've got skill overflow exception, and then we've got getting things done. So some hard-coded data here. But you get a request from the business, right? They want to know, hey, we've read this book recently that's saying that if you've got more than 7 people on a team, your team's probably too big, and we need to know which teams are too big. So let's write some code to solve that problem. One way you could do it is write a function like this called find too large team names. I'm going to ask the audience, so feel free to come off mute or type in the chat, what's the important part of this code, right? Like, what are the actual business rules of this? What are the parts that you care about?
Iterate over it.
Yeah, so we got to iterate over it. But there's like a special business rule. What was one of the things that the business cared about?
Well, you're hard coding 7 in there.
Yeah, the 7, right? So the business cared about knowing 2 things. They need to know which teams are greater than 7, right? So 7 was important, and their name. So that's the important part. But look at all the other code we had to write, the boilerplate, the cruft, right? All that other stuff. So this is how we would have done it with loops. But if we approached it with LINQ, our code would have looked like the following, where we could have said, hey, I want teams where member count's greater than 7, give me their name. So remember that question before I asked like what was important? It's right here. There's not as much boilerplate, there's not as much cruft. It is very straightforward here. And to me, this is one of the most powerful things about LINQ is that instead of me having to read through for loops and all this other stuff, the business rules are really just right in front of my face, which makes it easier to deal with. And comment in the chat, I didn't just hard code some identifiers in today. I'm going to skip over that because that's a different topic. So LINQ at the end of the day is a really cool concept because all it is, it's a set of operations that work on data independent of the source. Now that independence is pretty cool because it doesn't matter if that's coming from your database, a network call, hard-coded files, it doesn't matter. As long as you have a list of data, LINQ just works. That's crazy powerful. And even better is that LINQ is type safe. So if you're working in a language like C# and .NET, we love the compiler, right? Because if we make a syntax error or a type error, we want to know before running it. Well, LINQ does that for us. So I don't know how many of y'all have had experience with Entity Framework, but you know when you've written some Entity Framework code and you've mistyped a property or you've mistyped a select statement or something, and the code doesn't compile, yeah, it's because LINQ's helping you. You don't get that when you're writing raw SQL and then firing it over the wire, right? At that point, it's catching at runtime. This is the other reason why I like LINQ is because it helps you catch stuff soon, catch mistakes sooner. The other nice thing I like about LINQ, you end up just writing less code in general, right? If we assume that there's going to be a bug occur every X number of lines, then it might make sense to think about, well, how many lines of code do we need to handle a certain problem or solve a certain solution? LINQPad for the win from Gary Leonhardt. Absolutely. LINQPad's a fantastic tool. So this is some of the reasons why I like LINQ. The other nice thing about LINQ is this idea of principle of least power. The choice of language is a common design choice. The low power end of the scale is typically simpler to design, implement, and use, but the high-end power end of the scale has all the attraction of being an open-ended hook into which anything can be placed. So you may have heard Tim Berners-Lee, and what he's trying to say here is that when we are choosing a language, we should try to stick with the lowest powerful thing because it's easier to work with, easier to design, easier to use. The downside, though, is that you can't do everything under the sun. But guess what? Sometimes the constraints is actually a good thing. So let's take a little bit more about what I'm trying to say here. Here's the code that we had earlier for find two large of team names, right? Had this nice for each loop. So the question I've got for the audience is, what can you do inside the loop? What type of code could you write? Yeah, I like Haman's comment in the chat. Anything. That's right. You can do anything in the loop because it's very wide open. So that's why for each loops are so powerful, but it's because you can do anything. That means you also have to be a lot more careful. Versus if you're using where and select, what can you do in here? Not nearly as much. You have to really fight with the syntax to do something really unusual. And the minute you do that, it's going to abundantly stand out in the PR review. So even though where and select is not quite as powerful as a for each loop, the fact that it prevents developers from making mistakes and it brings the code a lot more clarity, I think it's well worth the trade-off. So how does LINQ actually work? So there's three concepts that we've got to understand, and that's what we're going to talk about next. You got to understand funcs. Without funcs, nothing works. You also need to understand generics, and we'll talk a little bit more about that. Last but not least, extension methods. With these three concepts, you can have LINQ. And you'll find that almost all of these concepts came out in .NET around the same time. So let's start with funcs. So func is an interesting data type because it is a value, but it's something that you've got to invoke, right? It's not just a static value like a string or a number or an array or an object, right? It actually has behavior that happens. So let's take a look at some example funcs just so we understand the syntax. So for example, we have a func bracket int that says, if you give me no inputs, I'm going to give you an integer. So an example implementation of such a function may look like the following, right? Open close parens, I'm always going to give you back the number 2. So it doesn't matter if I call it once, twice, 100 times, you're always going to get the number 2. This signature says, hey, I'm a function that says, if you give me a number, an integer specifically, I'm going to return you back a Boolean. So an example implementation of such a thing is our even function, where we're saying, hey, given this int x, I'm going to see if it's even, if it's mod 2 is equal to 0. And we can keep adding more parameters to the func. So for example, this is a func that takes in an int and a string and returns a new string. And so maybe the name of this function is called repeat, and it does all this crazy stuff. I don't necessarily care if you understand what I just wrote in that func. The bigger thing is, do you understand that the last parameter in the angle brackets is the return type, and then everything before it is the inputs. As long as you've got that, you've got a pretty good read of funcs. So you may not have realized it, but you've already seen funcs tonight. In fact, when we were looking at find two larger team names, the code inside the where block and select block are funcs. That where block, it's a func that says, if you give me a delivery team, I'm going to give you back a Boolean. And that select is a func that says, hey, if you give me a delivery team, I'm going to return you back a string. But the cool thing about funcs is that they're somewhat interchangeable. You can have an actual func type like we do, but there's some cool compiler syntactical sugar happening here that you can actually not just have inline funcs, but can actually point them to full-blown function definitions. For example, instead of having inline, I can bind it to variables like this, where I can actually have an isTeam2Large func and a getName func. I can also just make them their own methods and pass in their names to that. All of this will work. They're very interchangeable. So that's pretty cool. So I'm going to take a pause here. How are we feeling about funcs? Right? Kind of understand like, okay, got some logic in there. I have to specify some inputs and outputs, but otherwise, following pretty good. Seeing some thumbs up. I'm
They're
not seeing
pretty
anyone.
funky.
Oh, they absolutely are, Rob. Yeah, sure. What's up?
This is Brand, how do you know what signatures to implement?
Which signatures to
Well,
implement?
you implemented a blank one, you implemented one with an int, how do you know, can you go back a couple?
Yeah, let's go back a little bit. So how did I know that? Let's take a look at that is even. How did I know that it had to be an int and then return a Boolean?
Well, no, just a func signature, how do you know to do just an int or an int and a bool, what decides that? What is it, are you just adding any function with whatever signature you want to?
Bingo.
Or is it tied to like an interface or something else?
Nope. Anything I'd like.
Okay.
I just chose int bool, but I could have chosen a func that takes in 2 ints and returns an int, and it could have been doing addition.
And those that int and the Boolean are value types, but can also take in a reference type as well. So you can take in a person or a vehicle, something like that.
Yeah, and we saw that with the delivery team here, right? So and you'll see this a little bit later on in the presentation, but where says you have to give me a func that takes in an input and returns back a Boolean. That is actually one of the requirements. Otherwise, the code won't compile.
And where does that come from?
The
Is it
actual
something you have to make? Is it something you have to overload and make?
Nope. You'll see that. No, so where I like where you're going, Brand, because this talk's going to work smashingly for you. So where says that you have to give me a func that returns a Boolean, and the input is based on what was the type of the list originally. So in this case, since teams was a list of delivery teams, where automatically goes, okay, then this has to be delivery team to Boolean. It can't be anything else. So the compiler is forcing you to make those implementations.
Okay.
Great questions. So let's talk about generics. One of the things that surprised me about .NET is that generics weren't in the original design of the language, right? Like if you wanted a number list and a string list and a decimal list and all that, you had to write them your own, like artisanally handcraft them. Blows my mind. So you've actually already seen generics in play. Anytime you're in C#.NET code, take a look for these angle brackets. The minute you see them, you've got funcs going on, or not funcs, you've got generics going on. So why are generics so powerful? Well, let's give you an example. Let's say that I was writing my own implementation of a queue. And so I've got a number queue. Now I'm doing a bad thing. I'm cheating. I'm using a list to model it, but that's okay. So I've got a private backing field called elements. When you new up the queue, it's an empty list. When you add an item into the queue, we add it to the end. And then if we're popping, we're going to take the first element off the queue and return that and throw an exception if it's empty. And that works great for numbers, but at some point we're going to need to use a queue for other types. So for example, like a string queue. So here's its implementation. The fun question I've got for you all though is, what's the differences between these two chunks of code? Yeah, how many you got right? It's just the type. That's it. The implementations and the names are exactly the same. Anytime you find yourself writing code where the implementation is exactly the same, you probably have a candidate for generics. So let's go ahead and make the queue generic. First thing we're going to do is we're going to go up to the class level and we're going to get rid of the name, just change it to queue, and we're going to put that angle bracket T. Now, the minute I introduce the type at the class level and I want to use that type anywhere else, I'm going to refer to that same thing as a T. So now we're going to have a list of T's. When you call add, you have to give me a T. And when you call pop, I'm going to give you back a T. And you're probably thinking like, that's a lot of T's. But the nice thing though is now if I want a number queue, I can say, cool, new queue of int. And then C# and .NET take that and go, all right, sweet. Well, I'm going to use that int and put that in place of all the T's. So if I've got a number queue, I can only add numbers. I can only pop numbers. I can't get other types out of there. And then same thing with the string queue, except working with strings. So you'll see later on when we start implementing some of the LINQ methods that without generics, you would end up having to write a lot of boilerplate over and over and over again. So I'm going to stop here and just double check in. How are we feeling about generics? Not expecting anybody to be an expert, just enough to realize like, oh, okay. Just allows me to substitute on the types. All right, Gary's telling me to kick it. BC Boys reference, love it. Last but not least, let's talk about extension methods. So let's say that we're writing some code and we've gotten a requirement from the business saying, hey, when we're viewing the report and the date on that report should be in this format. 4 digits for the year, 2 digits for the month, 2 digits for the day. So we're like, all right, cool, we'll write some code, right? We'll use toString, we'll pass in the format. All done, right? Not too bad. Now, here's where it gets fun. The business and the product love what you've done. Super excited. However, and there's always a catch, right? Now we've got dates in this one format, but it's in a different format in other places. It'd be great if we can make this consistent. Seems like we need to reshare this logic everywhere. So if we need a consistent formatting for date, we should put that logic in one spot. And so we could write just a static class for this, right? Static class, static method. And we can say, hey, if you pass me in a date, I'll return it back to you as a string. Yep, that'll work. We'll have to update all the places to call this format date for display, but otherwise that would work. Another approach we could take though, and that's what we're doing, just passing in. But if we use an extension method, we could do the same thing. In fact, we can almost use this exact same code. The only difference is that we're going to add this keyword. Now, the minute we add this keyword, we've attached new functionality to a type, right? The datetime object does not have a method called format date for display, right? Microsoft didn't write that. That's not built into the language. But the minute we write an extension method, we can attach it to that type. And that's really powerful. Do you remember when we were talking about LINQ and we said it works independent of its source data? That's because it can extend. You can attach things to it that way. That's why it's so powerful. So the differences between the two are pretty subtle though, like when you go to actually use this in real code, right? In the top one, here's where we're using a static function. And then in the bottom is where we're using an extension method. Notice how we can attach to noun on the bottom, but before we had to thread it in. But if you understand extension methods and generics and funcs, you could have invented LINQ. And in fact, I thought I had a slide here and talked about the dates, and the versions, but it was like .NET 3, I believe, that introduced funcs and extension methods. They came out at the same time. Generics came out a little bit earlier. But once funcs and extension methods hit, LINQ came in the next release. But if you have all three, you could have been in LINQ. So much so, in fact, that if you look at the Microsoft docs on extension methods, you'll see that they quote that the most common extension methods are the LINQ standard query operators. And that's because they attach to the IEnumerable and the IEnumerable generic types. So even Microsoft themselves are claiming like, yeah, you would absolutely need to do this. But enough of me talking, let's actually start building some of this stuff. So we're going to build our own version of LINQ, but we're going to follow some principles. The first principle we're going to follow is that it has to extend the IEnumerable type because that's what real LINQ does. It's also going to have the same type signatures. So Brand, you asked earlier about like, why were we taking certain things? We're going to show you why that's the case here because we're going to follow the same type signatures. And then the part that a lot of engineers don't think about, but is kind of interesting, is we're also going to make sure it has the same properties of LINQ. Now, a lot of engineers don't think about properties of methods and functionality of LINQ, but it's kind of cool, and I'll show you. So let's start with the very first one. And now I'm going to use the industry standard terms for a lot of these things. For example, even though LINQ calls it select, almost no one else does. It's called map. Everyone else knows it as map. So I'm going to use that terminology here. So what map does is that if you give us a collection of one type it will convert it to another type, but you got to give us some mapping function, some way to convert from one type to another. And select has a couple of cool, or sorry, I said select, but map has a couple of cool properties. The first one is it maintains the length of the collection. So if you're used to LINQ and you've called select on an empty list, how many items do you get back when you call select on an empty list? You get 0 back. It maintains the length. If you call select on a list of 5 items, you're going to get back a list of 5 items. So that's kind of cool. The other thing that LINQ guarantees you when you're calling map is that the results are all the same type. So if you have a list of numbers and you're converting them to strings, well, that list of strings, they're all going to be strings. You're not going to have some of them are strings, some of them are numbers. Nope, they're all going to be the same type. So you don't have to worry about something slipping in there. Also, you're guaranteed that the resulting collection cannot be null. So even if you call map on an empty list, you're not going to get null back, you're going to get empty. So that's also a really nice way to remove a lot of error handling code. That's the reason why I like LINQ so much. So let's see how we can build our own version of LINQ by refactoring, and specifically on the map. So here's our delivery team from before, right? Name, team lead, member count, same definition. And we've gotten a requirement that says, hey, given a collection of delivery teams, we need to see their names. We go, all right, cool, let's write the following. So we create a list of strings. We're going to for each through teams, and we're going to add their name to the list. Boom, awesome, works. The problem then becomes that we end up using that code all over the place. So then we get pretty smart, and then we go, all right, let's go to an extension method. So instead of always having to copy that 3 or 4 lines of code everywhere, we're just going to put one spot called to get team names, use it everywhere. And all we've done is we've just plopped in that exact same logic, exact same code. I just put in an extensions class. But now business requirements changed a little bit. We got to build something else. We now also want to see all the team leads. So we go, all right, cool. So I'm going to short circuit a little bit and write a new extension method, but we'll create a list for leads, iterate through the teams, add the team lead to the leads, return leads. And we're going to put this in that same extension file from before. So our code looks a lot like this. Interesting. This code looks really similar to each other, doesn't it? Right? We're newing up a list for reaching through a list of teams, and we're returning the results, right? Oh, see, you're already thinking list of T there, Andrew, but we're not even that yet because it's still all delivery teams to strings. The only thing that's really different through here is just what are we adding, right? That's the only difference in this code besides some naming. Well, it seems like we need a way that given a delivery team, we need to get a certain property off of it. That sounds like maybe we need a func. So what we can do is say, all right, we've got an extension method called getStringValues. And it says, if you give me teams and you give me some function that given a delivery team, it'll return back a string, I'll use it. So now going forward, anytime I need to get string values off a delivery team, I can use this method. So much so, in fact, that here's what our refactors look like. Get team names from before. Yeah, all that code in green, throw it in the trash can, not needed. We can just pass in the func here saying, yeah, team such that team.name. And get team leads, same concept. Throw away the rest of the code in green. Don't even need it. So far, so good. Life's good. We've removed some duplicated code, still made it pretty clear. Business rules are up front. But like any good developer, we get more work to do, right? We're doing good, so we get more work. Now we got to know the number of the members of each delivery team. So we go, all right, well, we're going to add a new extension method called getTeamCount, write all this code, and we're just going to iterate, get the member count, add it to the list. Okay, this works, no problem. And then we get a little bit smarter and go, well, we've seen this pattern before, so let's go ahead and do getIntValues. So we have the list of delivery teams, and then we've got a function that says, if you give me a delivery team, I'm going to give you back an int, and same logic as before. In fact, the logic's so similar that if we look at the two implementations, what are the differences? Yeah, Tigran, you've got it right. It's just the types, right? And the one on top, it's using strings everywhere, and the ones on the bottom is using ints everywhere. Okay. Well, if the implementations are the same, the only thing that's different is the type, congratulations, you've got generics. So let's make this a little bit more generic. You would know this as map. Map says, if you give me a list of delivery teams and a function that goes from a delivery team to some other type, I'll give you back a list of some other type. So all I did was I took all the ints and all the strings, replaced them with the same name. But now that we've got this version of map, if we go look at what get string values does and get int values does, right? We don't need this code anymore. So we can axe it. Those methods, throw them away. The methods that we're using it, like called get delivery team names and get leads and get member count, here's what they look like. Teams.map, either the name, the team lead, or the member count as expected. Nice. Removed a lot of code, have one nice thing that does everything we need for select. That's pretty cool. Here comes the fun part though. Given what we've seen so far, is there any reason why this should only work with delivery teams? Is there any reason why we're constrained by that? And the answer is no. So the trick is that we actually introduce a second generic. We're going to call this one T-source. Naming conventions with generics in .NET is that they should start with T. But everywhere that we had delivery team, we just replaced it with T-source. So another way to think about map is if you give me a list of one type, let's call that type A, and you give me some function that can go from type A to a type B, I'll give you back a list of type B. And here's that code, and this will work like a top. And this is so good of an implementation that if you actually look at the Microsoft implementation for Select in GitHub, this is their code. Man, it looks real similar, don't it? And it has to. There's no other ways to write map such that it fits all the properties we talked about. It can only be written one way. Now, for the astute watcher, you're seeing that this is a to list. The reason why it is that Microsoft has some performance optimizations that happen on whether you're calling a to list versus a to array versus a to dictionary. So I picked the to list one because that's kind of what we're doing here, but otherwise it's exactly the same. But we can do one further. Remember we said that this had to extend off IEnumerables because that's what LINQ does. So here's how you would actually write it if you were only dealing with IEnumerables. Switch out list for the IEnumerable type, and the only thing that's different is this yield return keyword. Now, if you've not dealt with IEnumerables before, this is how you make something lazy, right? Is that this code will only run per items in source for as much as it needs to. So if you only take like the first 5 items, it's only going to run 5 times. If you want the whole list, it'll give you the whole list. Now, this isn't always the most performant way, but given the fact that we're attaching it to IEnumerable, this will work good enough. The big thing to remember when you're using map or select is that if you've got a collection of one type and you're trying to go to another, you're going to want map. That's exactly how you solve that problem. So we've talked about map. Let's talk about the next one called keep. Now, in LINQ, it's called where, and this is one of the few times that I think Microsoft got the naming correctly. In almost any other language or tech stack, it's called filter. And I hate the word filter because it's not clear. Are you filtering things in or are you filtering things out? So I prefer where. I also will use the word keep because we want to keep these things. So what keep does and what where does is that it gives you part of a collection based on some criteria known as a predicate. Now, a predicate is some function that will return back a Boolean. And keep and where have a lot of really interesting properties. The first one is that the resulting list that you get back, the length, is somewhere between 0 and the original length. So if you try to give me all the even numbers between 1 and 10, it can't give me back more than 10 numbers because there was only 10 numbers to begin with. So it can't generate more than what it had. It also can't give you back items that weren't in the original list. So if I call give me all the even numbers between 1 and 10, it can't give me back 12 or 22 because they weren't in the original list. It also maintains the order. So if the list was sorted 1 to 10, it will give me back 2, 4, 6, 8, 10, not, well, here's 8, here's a 4, here's a 2, here's a 6. Nope, it maintains the order. A lot of cool properties you get for free with that. So let's see this in action. Here's our delivery team type again. And we're asking that same question, which delivery teams have more than 7 team members? So I've fast forwarded us a little bit because we can go ahead and write the function called get to big teams, then move that to an extension method, and then attach that to the IEnumerable. So all I've done is that I fast forwarded us there a little bit. But this code works, right? For each of the teams, we're going to check the member count's greater than 7. If it is, we'll do a yield return. This will work. This will do everything we need, and we pat ourselves on the back. The problem goes is now we have a new requirement that says we need to figure out which delivery teams have Dana as a team lead, because if we have any team lead that's leading more than one team, that could be a problem. And we're wanting to make sure that Dana's doing okay. So we write this code, another extension method that's attached to delivery team. But this time we're checking to see if the team lead is equal to Dana. Okay, this works. But take a look at these two extension methods we have. The code for this looks really similar. In fact, there's really only one difference between the two, right? Anybody want to take us what the difference is?
It's your if statement.
Yeah, it's that if check, right? So I asked the question before, but it seems like we need to, oh, thank you, Sean. I was hoping somebody would pick up the reference. Yeah, criterion, that's right. So if that's the only difference between the two, what's a technique that we've seen earlier that allows us to have some flexibility on what to pull off from an object, right? You saw us with map that we introduced something, right, to allow us to pick that. Yeah, the func, that's right. So let's go and introduce the func. So because we're using this in an if check, we know the func has to return back a Boolean, otherwise we're going to have a really bad time. And because the list or the IEnumerable we're working on is delivery team, the func has to have the signature delivery team as an input, Boolean as an output. So Brand, I'm hoping that this is helping you kind of draw some dots about where are these types coming from, right? It has to follow the signature because we're using the predicate as part of the if check. So that's where the Boolean's got to be coming from. And the input has to be a delivery team because that's what we're listening for, right? We're not working with anything else.
So if I can point this out, I don't know if you're going to point it out or not. When I've taught some people about this, I said that, the special thing about what's being passed here as that func is it's not a value, it's not a reference type, it's the address of another method. And it's a function pointer. And which for some C# developers, that's kind of a new concept. For C++ developers, it's no brainer. So, but the cool thing is you get to pass in the address of a function. So I don't know why, I just love that.
Yep. So Tigran has some comments. It is a delegate. It can be, delegate is also a keyword. Yeah. And it can be null unless you're in newer versions of .NET runtime, in which case it won't be null by default. So now that we've got this func, we can go ahead and use this new method get teams by. So instead of doing this for each loop like we did before, we can say, hey, give me teams by where team member counts greater than 7. And then same thing for teams led by Dana. Code in green, throw it away. It's gone. Trash. Don't need it. So we've got this code and it seems to be working. But the question becomes, is there any reason why we only have to limit this to delivery team? Right? If we were to do this with another type, the only things that would have to be different would be, well, the types, right? The for each logic and all that would be perfectly fine. So much so, in fact, that if we switch it out for T source, implementation's perfect. It'll work like a top. So that's kind of cool. And this is such a really cool solution that if we compare this to the Where implementation from Microsoft on their GitHub, it looks the exact same. The only difference is that's got a to list here, but it's due to the performance things that we talked about from before. But it kind of goes back to there's really only one way to write where or keep that fits the criteria, except one other way. So I hinted at this before, but that predicate returns back a Boolean value, right? So what's the other way we could have tweaked this if statement such that it would still work and it would still compile and it would still fit all the properties from before? This is a little bit of a tough question, so totally okay if no one picks up on it. Do you remember when I said that I didn't like the word filter because it wasn't clear if it kept things out or if it kept things in or kept things out? This is why. You could have had if predicate add it to the list. You could also say if not predicate add it to the list. It would fit the type signatures, it would have fit the properties, but it's not very clear which one to have used. That's why I think Microsoft did a really good job using where here. I know that's not why they used where. They used where to keep up with the SQL syntax, but I like it a lot regardless. So that's map. That is keep slash filter. And anytime you're going to use keep is when you only want a certain part of a collection, right? If you only want certain elements. Last but not least, reduce. This is the most complicated one we're going to cover tonight, but it's also the most powerful. So reduce allows us to go from many things, like this basket of eggs, to a single thing, like a nice breakfast frittata. That's really what reduce does. So here is an example of using aggregate, which is what Microsoft calls it in LINQ, to sum up the numbers between 1 and 10. So you have an initial value, and then you have some reducer function. And the reducer function says, if you give me the accumulation so far, that's what ACC stands for, and if you give me some item off the list, I'm going to combine those two to be the new accumulation. So int total says, all right, I'm going to generate you the numbers starting at 1 and the next 10 digits, or the next 10 numbers. And I'm going to aggregate starting with 0, and then I'm going to take this reducer function. So the first call, it's going to get 0, 1, returns back 1. Then it gets called again with an input of 2. So you've got 1, 2, gives you 3, so on and so forth. Now, reduce and aggregate are really powerful because of that reducer function. You'll see why in a minute. So let's say that we had a criteria and a business objective to figure out how many total team members do we have. Well, one way we could write the code would be like the following. Total equals 0, iterate through the teams, total plus equal team.member count, return back the total. This is a real simple addition, right? Running total. We've written this code tons of times. We may have another requirement that says, well, I want to get all the team names formatted in a very particular way. So we go, all right, cool. So because we are really good developers, we know that we shouldn't do a lot of string concat. So we're going to use a string builder. So we knew it up. For each of the teams in the list, we're going to append the line of team name, followed by, proceed with a dash. And then we're going to turn back the string builder. Now, if we look at these two functions, man, they don't really look all that similar, do they? Right? Yeah, there's some similarities. Yes, they're both taking an IEnumerable delivery teams. Yes, they're iterating through that list. But it's different all over the place, right? The first one's using numbers and it's adding them. The second one is using string builders and using a pen line. That's pretty rough. But even though the types are all over the place, the steps are actually pretty similar. In each one of these, we are setting up an initial value. We then have some way to update that initial value. And then we're returning what the result was for manipulating that value every time, that accumulation. Anytime you find yourself writing code like this, where you've got some initial value, doing stuff to that initial value, and then returning the result at the end, you've got to reduce 100%. So let's rewrite these to be in the form of an aggregate. So whole bunch of generic soup here, but bear with me. So reduce, like I mentioned before, it takes a list of things and reduces it down to a single thing. So in this case, T result. You need to tell us what the initial value is. And a good way to think about the initial value is pretend if the list was empty. What would you want the result to be? So with the running total, right, if you give me a list of no numbers, then the result's going to be 0, right? That's how we came up with that initial value. And then once we have that initial value, we need this reducer func, which says, if you give me the accumulation so far, and now a delivery team, I'm going to give you a new result. I'm going to give you a new accumulation. And that logic, and that logic's kind of being thread through here in that for each, right? We set up a result to be the initial value, we iterate through teams, and then the magic is where we say result.
You skipped out for a minute.
Oh, gotcha. Okay. That's what I get for trying to do big waving hand motions in the talk. So apologies about that.
Just rewind about 5 seconds. You're good.
Yep. So the really cool thing about the reducer function is the magic's happening inside this for each. We get the result, which was the initial value, and then we thread it through that reducer function to get back a new result, and we're going to hold on to that. So we're always throwing out the old one. And once we've iterated through all the teams, whatever result we have, that's the answer. So that's what we return back. For those of you who have a little bit more of a comp sci background, this might seem a little bit recursive in nature, and that's because, yeah, it absolutely could have been written recursively, and that's kind of neat. But okay, we've got this reducer function. How in the heck are we going to use this thing? Well, here's why. So for a total number of members, our initial...
You're cutting in and out.
Excellent. Perfect. Nothing like technical gerbils. Okay. So not sure where you cut out, so I'll just rewind, go whoop, whoop, whoop. So we have our initial value of 0, right? And what we're saying for initial value is what would the answer be if there was no items in the list. So now that total number of members, if the list of teams was empty, then you have no members, so it'd be 0. Otherwise, we've got a team, so we're going to say, cool, whatever my running total was, get the member count, add that together. Then we can use reduce. Formatted team names, very similar. Our initial value is the string builder append line bit, because if there's no teams, then this is what our answer would be. Here's the teams in the company, empty. And our reducer says, cool, if you give me a string builder, our running total so far, and a delivery team, here's what I want you to do. I want you to do the append line. And then we call the reduce function. So that's kind of reduce. This is our final answer to it. But same question as before, is there any reason to limit it to the delivery team? The answer is no, right? In fact, if you look at this code, the only place that delivery teams ever used is on the list of items coming in, and then as part of the reducer function. So let's just switch those out to be a different type. In this case, we'll call it T-source. And the implementation is exactly the same. The cool thing about reduce is that if you compare this to the Microsoft implementation, and I think Tigran was mentioning this in the chat, that they have a little bit more null checking type stuff here. But if you take a look at those last 5 lines, they look almost exactly the same as what we wrote for reduce. And it has to. There's only one way to implement it, right? So remember we talked about the principle of least power from before and why we typically want to use that? Here's a good example. Between map, keep, and reduce was the most complicated one, wasn't it? Right? A lot of type signatures, a lot of things to process, right? Well, there's a reason why. The big reason is because you can actually rewrite all of LINQ to be a reduce, all of it. You can't write reduce as a map or as a filter, but you can absolutely write map as a reduce and a filter as a reduce. And I'm going to show you how to do that. If you're wondering why the ducks are here, just imagine that I just said what in a very JavaScript S meme from, I think, circa 2014, which should give you a hint of what my humor is. So let's go rewrite this. So if you're rewriting anything as a reduce, there's 2 steps. What's the initial value? And then how do we combine that value with an element from the list? If you know how to do those 2 things, you can do a reduce. So here's our map from before. Step 1, what's the initial value? And really that question is, what should we return if the list is empty? Right? Think back to our properties of LINQ. If you call select on an empty list, what do you get back? We get back an empty list, right? So if we're getting back an empty list and we're using enumerables, we're going to use enumerable of tResult.empty. They'll give us back an empty list. So that's our initial value. So once we rewrite our map via reduce, plop the signatures in and everything, and then we do return source.reduce enumerable starting with empty and then the reducer function, I can hit control period on my keyboard and generate this reducer function. So this is it. If we can write some code inside reducer such that we can go from a T source to a T result, we're in a good spot. So we need to be able to convert it, and then we need to add that result to the accumulation, the ACC. So what do we have access to that knows how to take a T source and convert it to a T result? Do we have access to anything that will help us with that task? Remember that selector function that we were working with before? That knows how to go from a T source to a T result, so we can use it. So now that we've converted that T source to a T result, we've got to figure out a way to add it to the enumerable, and we can do that by calling its append method. That's it. That's how you can write map as a reduce. Now, is this the most readable code? That's debatable, right? You're having to read a func that you had inlined here to work with reduce. So I wouldn't recommend doing this for your production code, but I didn't ask you to write for your production code. I asked you, could we do it? And the answer is yeah, absolutely we can. So let's take the same approach for keep, right? Here's what our original implementation was. Same question as before. What's our initial value, right? If you call keep on an empty list, what elements do you get back? It's got to be an empty list. Can't return back anything else. So it's the same initial value. It's that enumerable.empty. So same trick as before. I write return source.reduce enumerable.empty of T source, the reducer function, hit control period, and I get this handy dandy boilerplate code generated. Now I've got two steps here. Got to check to see if the item meets the criteria. In other words, how do we know if we should keep it? And if we do keep it, then we've got to add it to our accumulation. Otherwise, we just need to return what we have. We don't need to add it. So we're looking for something that we have access to that says, if you give me a T source, I'm going to return you back a Boolean. Do we have access to anything on this screen that could maybe do that for us? That predicate, it knows how to take a T source and returns back a Boolean. Okay. So we can go ahead and plop that code in here, right? So if the predicate of item is true, we got to do some logic. Otherwise, we got to do some other logic. So if it matches, we're going to use that append trick that we used in the map from before, right? We're going to append it to the accumulation. Otherwise, it didn't match, so we're just going to return what we've built up so far. That's it. You just redid keep as a reducer. Now, once again, is it the most readable code? Debatable. But did we do it? 100%. So with that, you've kind of covered the top three, the holy trinity, if you will, of LINQ. If you understand map, you understand filter, you understand reduce, you have enough building blocks to build all the other LINQ methods. And in fact, when I am teaching someone LINQ, we actually take an hour and implement as many as we can. So you get into some fun ones when you're tackling the first or defaults, first, single or defaults. Group by is particularly fun if you like a challenge. But to make all of this work, right, because we covered a lot tonight, we had to understand what was LINQ. Why was it so important? Why was it so cool it could attach to different data sources? We had to understand funcs, generics, and extension methods, because without those three, LINQ's not going to work. And then we actually implemented our own versions of map, keep, and reduce, which was kind of cool. A lot to take in for sure, but even if you only picked up map, right, or only if you got just a little bit more comfortable with funcs, generics, and extension methods, that's a pretty good step up. The other thing to keep in mind is that LINQ's not magic, right? It's not, magical elves doing their voodoo behind the scenes, right? It's just a composition of three concepts, those funcs, generics, and extension methods, and that's it. So thank you all so very much for letting me come hang out with y'all this evening. I really appreciate it. Feel free to drop me a line. at Cameron@softwarementor.com. I love chatting with others about their experiences, and there's always going to be questions that come up after the fact that you're like, oh crap, I forgot to ask Cameron about this. Absolutely. I've got a QR code up on the screen. I know there was some questions in the chat about not being able to get to the slide deck. If you all are still having that problem, just someone put a message in the chat and I will delightfully solve that problem. Otherwise, you can always go to my website. And thank you, Sean. Wind beneath my wings for the second time this evening, sir. I appreciate it. But yeah, that's everything I had. Thank you so much for the time.
Awesome. Thank you, Cameron. Greatly appreciate
you.
it. Before we come off of the recording, does anybody have any questions? Okay. All right, I'm going to steal back host, and then I will cut stop the recording. And thank you guys for coming out. Please hang around if you'd like. We'll do some after presentation talk. But other than that, I will go ahead and stop the recording and hope to see everybody on the next user group meeting.